Problem 4-95. Solve the equations below. Meow. Letter A. The square root of the quantity of x plus 15 equals 5 plus the square root of x. There's a couple different ways we can solve this. Let's solve it algebraically first, and then we'll solve it in the graphing calculator next. So we need to break out our x out of the radical here, and we'd like to do the same thing over here. So normally what we want to do, the first thing here is square this side of our equation, which means we also need to square this side. So I'm going to take it here, and let's just go ahead here and say we're going to square this side, and then we're going to square this side. Now because the entire expression is under the radical here, the square root and squaring it, or inverse operations, are going to cancel each other out, leaving us with just x plus 15. On the right side, though, we have a binomial here. We have 5 plus the square root of x. So if we were to take that and multiply that, we have to think about it like it is 5 plus the square root of x times 5 plus the square root of x. So you're either going to need to FOIL it or set up your generic rectangle, and I'll do that. It's been a while since I've done one of these. So what we're going to end up with here, after I get it set up, let's say the square root of x, and we have plus 5, and we have the square root of x plus 5. And so the square root of x times the square root of x is going to be x. The square root of x times 5 is going to be 5 radical x, or 5 times the square root of x. Same thing over here. And then 5 times 5 is going to be 25. So let's put it all together here. We're going to have x plus 10 radical x plus 25. So that's what our right side equals when we take it and we multiply the binomial times the binomial. So x plus 10 radical x plus 25. Now, just like with any equation here, let's start trying to combine like terms. There's nothing that we can combine on the right side. There's nothing we can combine on the left side, so we're going to cross our equal sign. Let's go ahead and subtract an x from each side. I'm just dealing with the x that's outside here. I'm not dealing with the one that's underneath the radical yet. Let's do that. And I'm going to get my constants together. I'm going to go ahead and subtract 25 from this side and subtract 25 from over here. And we'll see what happens after we do that. So x minus x is 0. 15 minus 25 gives us negative 10. These x's give us 0. These 25s gives us 0. So we have negative 10 equals 10 radical x. Now, before we can get this x out of the radical, we're going to have to divide each side by 10. And negative 10 divided by 10 is negative 1, which equals the square root of x. What we'll notice now here is, what can we take the square root of that will give us negative 1? Well, there is no number we can take the square root of at this point in time to get negative 1. So this is not going to be a real number. This will actually end up being an imaginary number. But since we haven't talked about that yet, we can say here that there are no solutions, okay, at this point in time. There is no number we can take the square root of to get negative 1. So there are no solutions, or let's actually even emphasize there are no real number solutions. Actually, that's a better answer there. So no real number solutions. So let's take that part out there, because let's say there's just no real number solutions, because there actually is a solution to this, but we haven't learned how to do that yet. Now, if we were going to graph that there, or we wanted to check that by graphing it, let's look at what our original equation was. We had the square root of x plus 15, And we said that equaled 5 plus radical x, or the square root of x. At the start of this chapter, we talked about other ways that we could solve systems of equations using the graphing calculator. So what I'm going to do here is I'm going to take this and I'm going to set each of these up into its own function. I have y is equal to the square root of x plus 15, and I have y is equal to 5 plus the square root of x. If we graph each of these and then look for our x coordinate of the intersection point, that would be our solution. Now we're saying there's no real number solutions in this problem, which means that these should not intersect. Let's type them in and see here. So we're going to do second x squared, so we got our radical there. We've got x plus 15. So y equals the square root of x plus 15. And then we have y equals 5 plus the square root of x. And let's take a peek at the graph. Now I'm not in my standard window here, so it's kind of hard to see them, but remember, if you're outside of that, you could just do your zoom 6, go to your standard window. Here is our y equals the square root of x plus 15, and here is our y equals 5 plus the square root of x. Now on our standard window, they do not intersect, and if you want to look at it on a bigger scale, let's just go ahead and zoom out. So zoom 3, let's press enter and see if there's a point outside of that standard window where they may intersect. And you see here, as they continue on to the right here, they're just going to travel alongside each other. So therefore, there are no intersection points. So our answer that there are no real number solutions is correct. All right, let's slide our calculator away for a moment. And let's try the second one here. We've got letter B. We have the quantity of y minus 6 squared plus 10 equals 3y. Well, if I'm going to solve it algebraically, I'm going to move my 10 over to the other side here, so I have a binomial over here. So let's subtract 10. We have the quantity of y minus 6 squared equals 3y minus 10. And if I want to take this, I can multiply my binomials together, y minus 6 times y minus 6, or FOIL it. I should end up with y squared minus 12y plus 36. And I guess I didn't actually have to move my 10 over there. That was just kind of me. I don't know. It was fun, so I did it. Because now I actually end up moving it back. So I'm going to subtract my 3y from each side, and I'm going to add 10 back to each side there. I guess I really didn't need to move it like I said, but whatever. So we have y squared minus 5y plus 46 equals 0. Well, if we think about our factors of 46 that have a sum of negative 15, I know my factors of 46 are 1 and 46, and negative 1 and negative 46. I also have 2 and 23, and then negative 2 and negative 23. And since 2 and 23 are both prime, this is not going to factor. So we're going to have to look at using the quadratic formula in order to come up with our solution. Let's take it, let's set it up here. A is going to be 1, B is negative 15, and C is 46. That looks wonderful. So x equals the opposite of negative 15 plus or minus the square root of negative 15 squared minus 4 times 1 times 46 all over 2 times 1. That looks awesome. So x equals 15 plus or minus. We have our square root of 225 minus 4 times 46 would be, well, 4 times 50 is 200. And then if we subtract 16, we should have minus 184 all over 2. 225 minus 184 should give us 25, they went 41, so 15 plus or minus the square root of 41 all over 2, which is the same thing as 15 plus the square root of 41 over 2, and 15 minus the square root of 41 over 2. Man, this looks like a bunch of fun. So let's get out our calculator here to help us out. So let's get out of our graphing mode and let's just type in these values here. We're going to have 15 plus the square root of 41. So I'm going to take that, see what that is, and then I'm going to go ahead and just divide it by 2. And I get that the value of my first one here is going to be approximately 10.7. We'll round it, that's okay. With numbers like that, that's completely fine to round it off there. And then let's do the second one here. So let's do 15 minus the square root of 41. And let's divide that one by 2 as well. And we should get about, let's say about 4.30 or 4.3. So that's our other approximation there. So what's the values that we're saying that our y should equal here in this problem, because our variable ends up being y? Let's look at checking our answers by doing the same thing we did on the other problem. Let's plug in one side. Let's plug in y is equal to the quantity of y minus 6 squared plus 10. Now notice when I put it in the calculator, I have to turn all of these y values, or this variable, I have to change it to an x, because the calculator only reads the input as x on, it's the way it's set up here. So let's do x minus 6, we'll square it, and then we'll add 10. And then let's go down to the second one here, and then we'd have, instead of y equals 3y, it'd be y equals 3x. So if you have questions about that, make sure you do ask your teacher. But so I'm going to do zoom. I'm going to start out my standard zoom window here. So I have negative 10 to 10 both ways with x's and y's. And obviously it must not have fit on here. And we look up here, we know that our locator point for our parabola is going to be 6 to the right, and it's going to be up 10. So we're going to be somewhere like right around here. So let's take it here and let's just let's increase our zoom window here. Let's do, you can either zoom out, or I like to do a zoom fit sometimes here. Let's see if that one works. So there's our parabola coming down there and opening up. There's our line going through. It looks like it almost cuts it. Let's get that second intersection point here. So let's just adjust the window a touch. Let's go to our max. Let's change that to 20. Now we should be able to see it. And you should remember here that we can do our intersect function. So let's do our first curve. We got enter. Our second curve, enter. And so our intersection point, we get 4.29. Well, that's right around 4.30 there, so we rounded, remember? So that one is correct. And then let's do our second one. Second, trace, number 5. And we're going to need to arrow over a little bit closer to that intersection point. Enter, mark your second curve, hit enter on the guess, and we should get the intersection point would be 10.7, which is what our other one was. So we know that one is correct. So for letter B, our answers, 10.7 and 4.3 or 4.30 would work as the correct answers for this equation. For letter A, we ended up saying that there were no real number solutions because they did not intersect there. Those would be your two answers for problem 4-95. I hope this helped. This is Mr. Boyd signing off.